All right. What's going on this weekend? My other class was slightly attended as well, so I don't. It's just that time of the semester, right? It's hard to keep going, but we got to keep going. Um, so today we're going to take a look. Well, first, let me get back. Exams, I shall get to them tomorrow. I'm finishing up my 210. I got a little sliver that I take everywhere with me, and I get that last bit I should be able to get through today, get theirs posted, and then I will get working on. So I haven't even taken a look at the exams from last Thursday, but you'll see those over the weekend, hopefully sometime Friday, but certainly by Sunday. We don't have another test until the final, so that's kind of gives us a little bit of space here. And today's lesson is going to be very heavily dependent upon a graphing calculator, graphing tools, because you're going to be able to see everything. It's also basically, we're going to understand what a tangent function would look like, what the standard tangent function, and then it's a matter of doing transformations to it, moving it left, right, all those kind of things. Okay, so let's go ahead. So we're in 4.6, graphs of other trigonometric functions. It really should say graph of tangent function because that's the only ones that are in the homework. Although it would apply to some, I guess, secant, cosecant, and cotangent. We'll look at those probably later, but we're going to look at these graphs. So I want to start off by, instead of having a more formal presentation, we'll just kind of examine it. We're going to look at the notes, and from there we're going to graph a bunch of trig functions and see how we can use the technology. So this will be maybe a class session more on how to use the graphing calculator than anything else. All right, so let's come here, do it in blue. So we know how to graph the sine and the cosine function, or at least we talked about it, so hopefully we've got those in our minds, right? The sine function in general would look, it starts at 0, 0, goes up, comes down, and back up. And actually doesn't really start, I mean, there's negative sides. It goes on in both directions forever. And it has a period of 2 pi, so after 2 pi it just repeats. It's a wave function. Cosine function do that here, is one that starts at, because when x is 0, the cosine of 0 is 1, and it comes down and goes back up, and then it's sort of, that's one period, that's 2 pi there. And again, but it also continues on and goes up in both directions, up and down, so that wave function, right? So if we have those as a visual of what those functions look like, what is tangent in terms of sine and cosine? It is sine over cosine. It is a ratio. It's a rational function, sort of, right? It's a ratio of the two, so that's a rational. What happens? Oops, not sine. What do you remember happening to rational functions whenever the denominator becomes 0? Good. So whenever we get a 0 in the denominator, it's undefined, it's division by 0. And what does that look like on a graph? We have those dotted lines. We call them asymptotes. Kind of sounds like a profane word, but it's not. It's a Greek word that means to get close to. So what do we expect to see on the tangent function whenever cosine of x equals 0. We would expect to see division by 0, which will show up as asymptotes. Okay, so let's kind of build that here. We're going to kind of see what's happening, and then we're going to actually graph it to see if this is what we get. So when is the cosine function 0? It was right here that if, and again thinking back to the unit circle, that is at pi over 2. And then it does it again here at 3 pi over 2, the bottom of the unit circle. So that's where it's equal to 0. And if we go back to the negative direction, it'll do it here at negative pi over 2. So if we kind of went that way. So what we can do here is we'll set up the tangent function at pi over 2 and 3 pi, I may be squeezing it together, but, and then at negative pi over 2, because that's where cosine equals 0. Because of what we talked about, we're expecting maybe some kind of a asymptotes. Yeah, this actually should be pi. Let me make a more scale drawing. Whoops. Let's come back here. So it's pi over 2. This would be pi, and pi over 3 would be over here. 2 pi over 3. 3 pi over 2. Okay. Okay, so this is where the asymptote would actually be, and it looks a little bit balanced, right? So in between here is pi, in between here is a distance of pi, right? So what we're going to see is tangent will have a period of just pi. It'll repeat what goes on between here. The other thing we could talk about is what happens to a rational function when the numerator becomes 0. So when sine is 0, we get 0 over something. As long as it's not 0, where, yeah, exactly. That's where it's going to be equal to 0. So where is sine equal to 0? At 0, at pi. So we can kind of, oops, let's set that. I switch colors. So we should have crossings right there and there. Everywhere sine is 0, we will actually get it crossing the x-axis. Those are our x-intercepts. That's where y equals 0. And then just what does a graph look like as it gets close to an asymptote? It'll kind of go like that. And on this side, it should go like that. So this is the positive. And in this quadrant, that's the fourth quadrant. Fourth quadrant, x is positive, y is negative, so tangent's negative. Go ahead.
I was going to ask if that one goes up, if there's a third one there, it mirrored the one on the right.
Yeah, they will. Yeah, so then there'll be another one over here, and they keep going forever.
I thought there was one that like made a parabola in the middle, and
You're thinking of secant and cosecant. Cotangent will be like this, but it'll be reversed because it's cosine over sine, so it moves it. So it's, yeah, it looks similar to that. And then the cosine, cosecant, and secant functions have those U shapes, which we're not going to talk about in this lesson. I think we do it in a future lesson, but yeah. And again, a lot of these, what you'll do is you'll just go to your calculator and graph them, and then take a look, especially through the homework. A lot of what the homework does is they give you the function and they ask you to match it to a graph. Or they give you a couple functions and a couple of graphs and ask you to match them up. What you can do is you can graph them to see which one actually matches up. So most of what goes on, so this is what tangent looks like. What they will do is then they'll say, well, what would tangent of pi x plus pi over 4? Well, if I add something inside of a function, what does it do to the function? Moves it left or right. If it's adding, it moves in the negative direction. If it's subtracting, it moves it in the positive direction. So it's just going to move it left or right. If I were to add something on the outside, which I'm not sure they do or not, what would this do? That would move it up or down, right, on the outside. So that's basically what this lesson is about, is now that we know what tangent looks like in general, what would various transformations to the tangent do? Okay. Let me shrink that down. So I'm just going to pull up the notes. So that's what the notes kind of go through, right? Tangent is sine over cosine. They give us the x values. These are from the unit circles. Are coming, yeah, you could take it and notice every pi over 2 we get undefined. At 3 pi over 2 we get undefined. At pi we get 0. At 0 we get 0. So those are exactly what we were talking about. When sine is 0 we get an x-intercept. When cosine is 0 we get an asymptote. Okay, and then it goes ahead and draws it for us, maybe a little bit nicer than I did because it looks like they use Desmos. But this is what the standard generic tangent function, tangent of x, looks like. Okay, so we kind of get that in our mind. What we're going to do now is, as we do transformations, be able to figure out which transformation goes with which one. Stuff like this. And again, we can kind of look at the things we look at is where are the asymptotes. And remember from the original one, there is one period that wherever these asymptotes are, that forms one period, right? So the standard period for tangent is actually pi. It repeats every pi, a distance of pi here. So one of the things we can do is we can try to figure out what the period is. And what we do is, instead of using 2 pi over b, like we did with sine and cosine, we use pi over b, because it's only got, that's its period. Okay, so we'll take a look at these analytically. And then you can also look where are the y-intercepts, or the x-intercepts, where are these. But I'm also going to show you, we can take, sort of anticipate what's going to happen, and then we'll be able to match the graphs pretty good. Okay. So first of all, let's wanted to go into Pearson and actually get into a couple of the homework problems. What I want to show you is how you can set up your calculator so that you can get the window set up so it matches the graph, and it'll make it easier to match the graphs. Okay. So let's just pull up a couple of the homework problems. Oh, good. I forgot to check if it was even showing up there. This is 4.6. We are going to preview. So this is a type of question where we're going to match which function goes with which graph. I'm going to make one of these graphs big. I think they're all about the same. Yeah. didn't help much. Oh, you can keep making it bigger. So what I'm going to show you is how to use your graphing calculator to sort of graph each one of these and make sure it matches up. One of the things you want to do is make sure that the window on your graphing calculator matches these windows so that the picture will look the same. Because if it's too big or too small, it'll look different, right? It might be hard to match up. So what I do is I see, okay, this window, the y's are going from -6 to +6. The x's are going a little bit more than -pi/2, and it looks like it goes a little bit more than pi. So when I pull up, and unfortunately at this time all I have is a TI-84. If you have a TI-84, this will be helpful for you. If you're using a Casio, the concepts are the same, but the process of doing it will be a little different. So then I would go to y equals on my calculator. We're going to put in tangent. Just tangent of x. Let me, let's do it again. Tangent x. Okay, this is just to get it set up. I'm going to set the window up, and so there's an x minimum and an x maximum. So those are the x sides. I see pi/2. What's a little bit bigger than pi/2? What's that? Yeah, maybe maybe -pi/. See, oh, this is -pi/2 would be down here. We go negative, maybe 3pi/4. It's kind of try to figure out how there. So we go from here to pi/2. There's a tick in between there. That must be pi/4. Okay, so I'd go maybe -3 pi divided by 4. And if you want to just go to -pi/2, that would be okay as well. And when I enter this, it calculates it for me. And then this is pi, but it's about a pi/4 bigger, so that must be 5pi/4. And again, if you just went to pi, you would be okay. The y values I want to change, so the y minimum is -6, and the y maximum is +6. Y scale and all. I think I don't play with those. It's how often they do markers and stuff. So I think that's okay. I'm going to change them to 1 and see what happens. I think it makes it a little easier. And then I'm going to graph it. It's not too busy. So that's what it's looking like for a standard one. And notice a standard trig or tangent. My window's fitting, and it looks about like what they've got. What I would do next is then I can graph each of these, right? I can go y equals negative tangent x -2. Okay, let me draft that. So I'm going to show you, there's this key on your delete key. Above it, it says INS. That's for insert. So I'm going to go second insert. That lets me put a negative in front. It's a helpful one so that you don't have to completely retype. You could just retype it in there, okay? And then I'm going to have tangent of x minus pi/2. So now when I go to graph this is the actual graph, and that minus pi/2, what should it do to the tangent? Move it in the positive direction by pi/2, and it appears to have done that. Now if you wanted to leave the standard tangent in there, that's also another, I mean, you could also graph it at the same time. so that you can see, yeah, it moved. Not only did it move them, what else did it do? That negative caused a reflection. Okay, so it moved it and reflected it. That seems pretty good. So I'm looking for something that looks like the blue one, and so I can go through here. So these don't have the reflection. This one of these two has the reflection, and see, now I can look at, it's going to cross here. Which one of these two? Well, there's the y-axis. That doesn't look like it. That one looks like it, right? It's going, so you can actually visually match them up. And at the same time, take a look at what happened to them. That negative reflected it and shifted it. So now I can say, okay, number 3, that's this one that I worked with. I just drag it down here. Not that one. Part of this is I also want to see there we go, and then we'll check it. But you could do that with each one of them, graph it. But as you graph them, I ask you to kind of think about what you've done with transformations and see if you can kind of predict and then follow it up. And by doing this, if you're wrong, the graph will show you right away, and you say, okay, I'm wrong, it did this instead of this. Like I got surprised, I wasn't expecting the flip. Oh, right, that negative made it flip. So you will see each time, look at why it's different. So have the graph of the standard tangent, which is, I do it in red. If you don't have one that has, you don't have one that's color version, maybe don't do it with that. You could also use Desmos. Desmos is a good tool to use, again, for learning. But again, on the test, you want to be able to use your graphing calculator. Okay, let me, and then again, you could do all of these, and pretty much, as I went through, oh, I didn't check, but we would be fine. They have a function, and then this one, there's just one, you've just got to choose the right one. If you do the same thing, and again, here you'll notice the y values are just going from -2 to 2, so I would do my window that way, and you could adjust it. Sometimes you could keep the windows the same, but if you if you need to, if it's not looking right, go exactly with what they have, and you'll be able to visually match your graphs up. But once you do that, also take the time to understand why that graph transformed that way. Oh, that was a translation to the left or the right or up or down, or oh, there's this negative, so it got reflected. And again, you can use these plus signs to make them larger so that you can actually see what's going on, but graph each one. Okay? But the biggest part is get your window, because I've told in the past, I'll just graph it. Oh, they graph it. But then their window is like too big, and you got too many things going on, you can't really tell. Make it the same size as what they're showing you. What I'll do is I'll show you in Desmos the same thing. And again, I like Desmos because it's in color. It's a little easier to use. It's great for learning, and sometimes a little bit faster. But if they made a little handheld that wasn't connected to the internet, we could use them in every class. But this is what we have. So again, I would do maybe a standard tangent. But then and then we can graph the new one. What we want to do though is come to our settings here. This is how we set our x values, and usually this step is important. So I could see that it was going every pi/4 because they had pi/2 and they had a line, so every line must represent pi/4, so it'll step by pi/4. And then again, what did we go to? Maybe -3 pi/4, and this one went to 5 pi/4. And again, it just shows you enough. And then yes, then the y values, they're already going from -6 to 6, close enough. You could leave it as is, or if you want to be exact, they only went to -6 and +6. So we could change those. But the key part is here, and this step is how often it's going to graph it. So we got pi over 4, got pi over 2, and notice we could match up this graph, and then you could graph negative tangent x minus, what was it, pi over 2. And for pi on Desmos, you just type pi and it'll get the pi sign for you, so it's pretty quick. And so we see that we had this standard, the red is our standard tangent. This is the transformed one, so it moved to the right and it got flipped. Okay, and because the window is the same size, I'm able to visually see, hey, it's a visual. This is the one it matches up with. So I'm going to get the homework right, but I'm also going to learn about what's causing these transformations. Okay, because you'll see that, and you'll say, okay, that negative pi, it moved it to the right, but the negative on the outside flipped it. Okay, and that's all the homework is doing, is matching up these things. And again, we could also, the thing with tangent, because the way it looks, you could have an amplitude, like I could do 5 tangent. With tangent, it's a vertical stretch, so it doesn't look too much different other than that. But again, you could also visually see these things if we do these transformations outside. You can also see, let me take that one off. The other thing you're going to see is there'll be like a multiplier in here. Let me just take this part so we see one thing at a time. Let's multiply by, let's see, it's going to be pi over b. Pi, let's multiply by 2. If I multiply by 2, what should happen? The period changes. I believe it'll cut it in half. It'll either cut it in half or it'll double it. If you're not quite sure, I think it'll cut it in half, but if it doubles it, I wouldn't be surprised. The thing is, the nice thing is here, I can see exactly what happened. Oh, it's half. It's only going to -4, right? So let me take the negative off so it's a little bit clearer. It cut the period in half, right? But again, if in a homework problem, I could match it up with the correct graph now, but I also see multiplying by 2 and remember, inside it always does the opposite. If I was dividing by 2, that would stretch it out and make the period 2 pi, right? I can easily see that, and that's what I see this activity as. Let's see if we divide by 2. Notice it stretched it. So that's, if you'll do that with each of these, you'll see graphically, see the standard tangent, do it in red or some other color or whatever, and then do the new function and see how it's different than the standard tangent. That's what this homework is all about. You'll get through the homework relatively quickly because you can match them up, but you're going to learn as you do each one. And then by the end, you might even not need to graph, although you will always be able to. On exam questions, you can always use your graphing calculator. So that's why I show you how to use the TI-84 calculator, because that's the one you probably have with you. Get comfortable doing the graphs, but Desmos is a very powerful and easy way to kind of do the learning part of it and see how it's adjusting. But if you do that again and again throughout the homework, which is not overly extensive, you'll get through the homework fairly quickly, but you're also going to learn deeply because you're going to do it that many times. Questions? Let's take a quick peek to make sure I looked earlier, but let's see. I want to make sure we don't oops. See, jump to this one. So when I looked this morning, I thought all I saw was tangent. Maybe I jumped around. I missed the secant ones. Secant ones are going to do the same thing, but just, again, it doesn't matter what function it is. The one thing, I'm glad I did, your tangent, your TI-84 calculator does not have a secant function here. You know, they have tangent, they have cosine, they have sine. The newer ones might, and they might have them somewhere like here, but the thing is if we want to graph the standard secant function, how would we do it? 1 over cosine. So secant we're going to graph as 1 divided by cosine. And we've already got our window set up for most of these, although we'll see like down here it's going from negative 6 pi to positive 10 pi. Let me go ahead and set up the window. So I'll go negative 6 pi to 10 pi. And it looks like it's only going from negative 2 to positive 2. So again, this is the key part. If you'll do this, the rest, you'll just get chances to explore, and everything will work. Well, that's what it's looking like. Of course, I haven't done the part. What they have graphed on these, remember, since it's coming from the cosine, if I graph it with the cosine, you'll see how it's a reciprocal of the cosine, right? So where the cosine equals 0, we get asymptotes, and where the cosine was at 1, we get that flipping. So that's where we get the U shapes. Okay, so you can see that. And then, again, this one wants secant of x over 4. So I do cosine of x divided by 4. And again, you may want to, since they're also graphing the cosine divided by 4. And we see it spread out this way. So now what I do, which graph is the correct graph? I'm able to match it up from here, right? It's right on the y-axis, so this one's not it. This one must be it. Yeah, so it's got to be B. Visually, I'm able to match them up, but I can also anticipate what happened. What happened when we divided by 4? It stretched it horizontally. It did not move it. It just stretched it. Okay. And just remembering from transformations, that's hopefully what I would have expected. But we can reproduce the graphs of what each one of these do, as long as we know how to do it. So secant is 1 over cosine, cosecant 1 over sine, cotangent 1 over tangent. So most our TI-84s have the 3 functions: sine, cosine, and tangent. When you're using Desmos, for Desmos, I'll just show you one more. You can actually, down here, they do have something. They've got the functions. If we come in here, they've actually got cosecant and secant and cotangent. Looks a little prettier to just be able to put it in as secant x divided by 4. And again, we see what it's doing. We haven't adjusted our window or anything, but and then let's turn these ones would just turn off. And again, we could adjust our window to this one. They wanted negative 6 pi. To 10 pi. And the y's are okay. Negative 2. 2. Make it a little bit bigger. I did something wrong there. Oh, negative 6 pi to 10 pi. So again, you could graph it here. You'll see it that, but they have the functions you can pull up. Just on a TI-84, you have to know how to put those in as a reciprocal function. Questions? We did that all in like 30. Yes. How did I get the asymptote? How did I? It's whenever we're dividing by 0. So for tangent, we looked at where does cosine equal 0, and that'll do it. When you graph it, you'll kind of be able to see the asymptotes. Turn this one off. This is kind of you kind of see where there's those spaces, right? But now that you brought it up, let's go back here and let's see secant. Let's do that. You can actually draw them in. You could kind of see, yeah, it looks like at negative 2 pi and pi. That looks like where they're at. You could actually draw in an asymptote. And you can see, yeah, that looks good. A lot of times if you want to make them pretty, you can come here and let's make it a dashed line to make it an asymptote. You could make it red if you want. But you could actually draw them in on Desmos. You can't on the TI-84. But you'll have to kind of see it. It's a space where, hey, that they start heading off to infinity. That's where it's going to be. The way you find it analytically is you find where the denominator part becomes 0. And you find all your x-intercepts wherever the numerator becomes equal to 0. Which again never happens on secant or cosecant, but it does happen on tangent. But use your graphing tools to explore. Graph the original function, graph the changed function, and just see how they're different, right? And you will pick up all the. That's basically what this is about: is the transformations of tangent, secant, and cosecant, and probably cotangent. Let's just take a quick look here. So we picked up there was secant. In the notes, I guess I went by the notes as well. In the notes, there was just the thing on tangent. So, and again, you can graph all of these, and then you'll be able to pick which one is correct. Again, so this is a little bit of a more transformations taking an absolute value. So negative stuff would become positive. So again, just go ahead and graph it. Try to anticipate before you graph it what might be happening, but then go ahead and graph it and see, and you will learn that way because you see what's doing rather than trying, I don't know, sometimes I kind of have an idea, but if I'm wrong, I want to find out I'm wrong quickly before I, become too attached to wrong answers. So if I can see them quickly by graphing, I'll see when I'm right, when I'm not, and it will train me as I do this. It will train you as you do that. All right? Let's see. Let's go down. There's only 10 problems. I thought there were more. Maybe not. All right. So you're welcome to start work. Yes? Cotangent, COT? Yeah. You could graph it as cosine over sine, or you could graph it as 1 over tangent. Both of them will give you the same graph. Yeah, good question. Good question. All right. That's all we have for today.